And we are coming to the last presentation. It's about the generic CAN bootloader. So Holger has already presented um, that we have a lot of working groups and they are working on a lot of documents. They add new functionality and there's often a requirement maybe to handle new functions, to remove detected errors, or to react on new requirements, maybe security requirements, to update the local firmware of devices that are already deployed in the field. And we have already, since a couple of years, a document that describes in principle how the bootloader functionality should be handled, the firmware update over the CAN interface should be handled. But there are a lot of degrees of freedom in this document, so that if two or several implementers implement according to this document, there is a certain probability that they end up in solutions that are somehow similar but cannot necessarily be treated by the same tool but need some adaptations. And therefore, the technical committee took action, founded a task force, generic CAN bootloader, to harmonize somehow the activities around implementing bootloaders. So to come to, at the end of the day, to a result where you can handle the updating of an embedded device firmware via CAN with a very same tool, independent from whom the device is that you want to update. So let's come a little bit to the topic. What's a bootloader? What is the definition here? So a small operating system or application designed to download firmware in an embedded device. So MCU's internal or external memory. Thus, it enables upgrades or changes of the embedded device firmware. So this we typically do because we have some errors detected. We want to remove them. We need some security updates, or we want to add some additional features. And as I've already explained, this is not something new. There exist already, let's say, toolboxes for CAN-based higher layer protocols. So it depends which CAN-based higher layer protocol is used. Then you can do it via the means provided by CANopen, J9039, UBS, etc. And for CANopen, the provided toolbox is the document 302 that gives us the possibility to hand over to a device a new firmware and to start it. So let's have a look to the document 302-3 that specifies the bootloader. And there we find the definition. A bootloader is a software in a CANopen device that is able to receive the data of a program downloaded and that can start that program. So far so clear. Bootloader is called active if there's no program software running that provides CANopen device application functionality. So we have a bootloader that can be either active or inactive, and if it's active, we can update the device application program. Whenever a CANopen device comprises a bootloader and the bootloader is active, the data object 1000 shall provide the value of the bootloader device profile if one or more programs are started that provide the functionality for a CANopen device. The value of object 1000 shall provide the corresponding profile number. Here, at least with that sentence, some kind of uncertainty starts because we have some doubts. What is exactly now the corresponding profile number? Which kind of number should we now reflect in the object 1000? And the more, let's say, inaccuracy starts if you read the last bullet point. It is not defined in the specification which objects are the mandatory part of a bootloader and how a bootloader can be detected by a CANopen manager or a CANopen tool. So this is up to a device profile. So this more interpreted means it is not really specified which kind of CANopen device functionality has to be supported when a device is in the bootloader mode. So typically, you as a device designer, you're interested in to support only a minimum that is really required to get the new firmware and to get the new firmware started. But now you have a lot of requirements. I will come to the use case later on, and you have to react on these requirements depending on the application field where your device is running. And this opens up a variety of bootloader implementations. This makes it very difficult for tool manufacturers, for host controller manufacturers to provide bootloader functionality in a standardized way, in a harmonized way to a variety of CANopen devices. So let's have a further insight to 302. We have their recommended handling that we at first check the application program that is running, that we can check the software ID, is it the right version, is it the intended, the expected version, and if there is the necessity to update, then I can stop the application program that's currently running, I can clear the program, and furthermore, I can then download the new, hand over the new program and start the new firmware. We will see this on the next slide. Furthermore, we have here a nice note that informs us if there is a specific write protection or authentication mechanism required, then it may occur here. So also here, this is let's say an invitation for implementers to say, okay, I have to do here some manufacturer specific things. Why not harmonizing here things that I can provide authentication function in a standardized way? So here you see the end of this flow chart, how you hand over the program and validate that the program is correctly applied and the device can operate in the intended way. And we have there also a set of parameters available in the object dictionary specified by 302 that I can treat this functionality. And we see also here a lot of optional functionality. Me from a host controller side or a tool manufacturer side, I cannot really rely on certain functionality. And that there's something to do, we see also here at CiA, when we go through the documents from Canon Automation that use bootloader functionality. I think one of the maturest one is the document CiA 417 for lift control applications. Holger has already mentioned this document. This document uses the bootloader, and the people specifying CiA 417 thought a lot, not only about the lift application, also about the bootloader handling. They have written their own implementation and users guidelines, CiA 814, as is depicted here at the bottom of the slide, where you see if a device shall get a new firmware, it has to be prepared to get in the right status. Then you need to activate the bootloader, you make the data transfer, and you restart the device. But it relies on 302-3. But of course, you do some simplifications. You say, well, I don't take the node ID that is currently in use, but I take a node ID 126. This keeps the implementation load on the client side rather low, and I get very easily the information. Is there a heartbeat, for example, 126? Then I know, okay, one device is in the bootloader mode. So we differentiate between a bootloader mode and an application mode. The trade-off is I cannot update the firmware of several devices at the same time, one after the other, as the device has to be in the bootloader and the node ID 126. We have to support the heartbeat so that I see, is there a device in the bootloader mode? I have a part mode protection at object 6005. And there's a file format specified with some identification labels, hash values, so that a device that shall be updated can evaluate, is this a valid firmware? The application profile for energy management, the CiA 454, was specified when CiA 417 was already existing. Therefore, this was taken as a kind of template, and it was said, okay, what can we reuse from the lift guides? And it was a lot. It differs a bit in the authentication mechanism. So the password protection, we have an object 6005A, and here we can differentiate between several user levels, which user is allowed to do what. So the end user, the system owner, the manufacturer, and so on. And the next thing where we have a differentiation is we have a certain link to the application state machine of the energy management system. So in the energy management applications according to 454, there exists a certain state that is called compatibility check. So any device in CiA 454 that has received a new application program and that is requested to start this application program shall then pass the compatibility check. This means after a new application program has been started, the host controller evaluates, is now this device in this setup suitable for this application? Does it fit with regard to voltage levels and so on to this application that we are running here, or would it cause any severe issues and therefore it is not allowed to start, not allowed to provide its application to the system? Nevertheless, both of them, CiA 454, CiA 417, if available, they are starting immediately their application program. The other way around, CiA 443, the device profile for Subsea Instruments is working. Here the devices, first of all, they are starting in the bootloader mode. And in the bootloader mode, the host controller has to evaluate are the correct application programs provided and which one shall be started. And furthermore, when the other ones said, we need a heartbeat, we need a fixed node ID, here we have the situation, keep the implementation of the bootloader small. We don't want to see heartbeat. We don't want to have a fixed node ID, but application use case dependent, we assign a right node ID via LSS. So I have to support the LSS service. Yeah, so we see the status last year. There had been several interpretations of CiA 302 already specified in the CiA environment. So we had several flavors of the bootloader mode. We have variety in switching between bootloader mode and application mode. This may depend on the network management state. This may depend on application states, on a successful password writing, or any mixture of these three attributes. Also, the node ID handling differs from profile to profile. We have seen now in the last example, LSS is demanded or is an option. In some applications, I shall take the node ID that the device has already in the current application. In further applications, I shall switch to a fixed node ID, typically the node ID 126. Some demand heartbeat and other CANopen services. Others don't want to see, for example, the heartbeat. There exist profiles that think about marking the application program. And starting from this situation, the task force generic CAN bootloader has been founded, and this task force has the objective to provide recommendations and specifications on how to treat typically challenges in case of updating the firmware of a CAN-based device via its CAN interface. And it is not the aim to make existing bootloader implementations invalid. It is just intended to limit the amount of future bootloader implementation variants. And when we started the work we had to figure out what are the use cases that we have in mind. And we saw here 4 different use cases. So the simplest one is that an engineer has in his laboratory the device, and with this device connected via the CAN to a tool, he wants to provide to this device now the new firmware. So it's a very simple situation. We have a single device. We can simply deal with the node ID handling. We have all the manager functions available to do our task. We have no security issues. A very easy use case. A little bit more challenging is maybe the end-of-line production, the use case B, where we want to provide the same firmware to various devices. And here we have to think about the node ID handling. Not all the devices can come up with the same node ID. So here maybe a layer setting services support is advisable. And furthermore, we have typically a tool that has manager functionality. This makes life easy, but depending on the use case, there's not necessarily the engineer available, familiar with CANopen, but maybe just some stuff assisting here the production line. So we have to think about at least about some security mechanisms against unintended misuse. So should be covered here. And a little bit more complex is if I want to do it already in the field, the firmware update. So I have to differentiate between devices. I have to put devices or intended devices into this bootloader mode and to perform the update. So typically in a one-to-one session, typically I may have manager services depending if I come via a tool or via the host controller. And of course, I need some security mechanisms to authenticate myself to the system, to the device, that I'm the intended person to perform now this update of the firmware at this device already installed in the field. And the most challenging application is the last one, where we say we are not physically at the application, but we come via the internet, via the cloud, and do a remote access to the application, and maybe not necessarily via the host controller, but via a certain IoT gateway that had been attached to the CAN network of this application. So here you don't have the manager services available, you don't have a CAN expert available on site. So this is the most challenging exercise, I think. And we also try to consider this firmware update over the air, as you call it. So we summarized in several slides here. I squeezed it a bit, the requirements with regard to the bootloader. So as I've said, we differentiate between a CANopen device or CANopen FD device in bootloader mode and application mode. So by the way, I say a CANopen device. So we started with the approach of developing a generic CAN bootloader. At the moment, generic means it's applicable for CANopen and CANopen FD. We are evaluating later on whether we can increase the openness also for other CAN-based higher layer protocols. But at the moment, this is the main focus, CANopen and CANopen FD. We are discussing the node ID handling, but it's difficult to find a recommended solution because there exist, you have seen the use cases, good arguments for any use case to use the fixed node ID or undefined node ID, take that one from the application, or to use LSS. It is a critical task to define which parameters, respectively, which CANopen device functionalities shall be supported in application mode and in bootloader mode, how to identify the devices in bootloader mode, object 1000. This we are discussing, which kind of CANopen services shall be supported. What about the handling of multiple programs? It's not necessarily the case that there's just one. And Furthermore, it's also the discussion, what about a rollback function? So if there's something going wrong with regard to the firmware update, can I achieve the manufacturer settings at least back or the previous state? And we have not only in mind the device being updated, but also the client, so that we say, how can a client behave in the best way to update CANopen FD device? How can this client authenticate itself to the devices that get the new firmware? What about the treatment of bottlenecks? Should we talk about fragmentation? Do we have to consider latencies if we do firmware update in a running system and something like that? Yeah, these are the issues treated by the group, and we have just started at the beginning of the year, more or less, with the real work. And first of all, we said we have in mind CANopen FD devices, and this eases the work for us a lot, because it is very clear about which device architecture we are talking. We know this device has an object dictionary. So all the CANopen device functionality, but in particular an object dictionary, where we know how can we access the device, where can we get the status of the device, and where can we hand over the data, the application program to the device. And furthermore, as it is a CANopen device, we can handle the device states, either the communication, which is very clear by the CANopen specification, as well as the application status. So the upper part of this diagram, this is more or less already specified in the CANopen/CANopen FD specification. Here, the green part, this is implicitly part of the CANopen FD specification, but here we have it now explicitly depicted that we consider also the application state machine and when starts the application state machine. And as this is clear, we know also the bootloader functionality is to be considered as an application. So a CANopen device in bootloader mode runs bootloader functionality as application, and the rest is a normal, let's say, CANopen FD device. So we do the initializing, we double check, is there an application running, or should I automatically start an application? And if I do so, I start my CANopen device. One would say, as in a normal mode with the application program, we say here in this use case now, we are starting it in application mode. The device operates as a drive and an I/O module, whatever. And if I stop the application, and then the device transits to the initializing state, then it states, oh, I don't have a running application, and it starts in the bootloader mode. And you see here, according to this diagram, we have also some security mechanisms inside where we say, okay, you have to authenticate yourself, and only if security access is granted, you can come to the bootloader mode, allow application download, this specific state here. And here you can hand over the new program, start the new program, and get the new application running. As I've said, this document shall apply at least for CANopen and CANopen FD. Therefore, we had also intensive thoughts about how can we make this. So it would be so simple just writing a bootloader document. But the problem is most of the function is already standardized in the document CiA 302 for CANopen. We don't want to touch it. It's stable, it's mature, but we want to use it as a toolbox and clarify how to use these tools in a harmonized way. And we extend this toolbox or adapt this toolbox also according to the needs from 1302, the upcoming CANopen FD document for network management and so on. So let's say a sum of the documents 302 and 1302 is then my toolbox considered in the document CiA 710 that provides a common understanding of using the available toolboxes for harmonized CANopen FD bootloader. And we see this, for example, then as a result, how can I identify that a device is in the bootloader mode? We are using here the object 1000. We inserted in the CANopen FD specification a specific function field. We have there now reserved the value 8 for indicating the device is in the bootloader mode. And when we inserted the specific function field in the object 1000, we double checked whether this would work in CANopen as well. And yes, it does. It's accepted by existing field tools and host controllers. So this means we can run the same solution also in classic CANopen. Then we have learned that we need to differentiate between application programs and configurations for application programs. So one application program may have several configurations. It is very application specific and manufacturer dependent. How many configurations belong to a single application program? Therefore, it is not necessarily visible via the object dictionary, which is the relation between application program and configuration. But at least you have here the ability to start or stop certain configurations, not only application programs. A very intensive discussion is ongoing with regard to the functionalities being provided in either application mode or bootloader mode. So we had, at least at the last meeting, about 2 hours, we discussed which function is really necessary. You have the one group that says keep the stack as small as possible, only support functions that are really, really necessary, leave away all the rest. And you have others that, for reasons, I would need this specific thing, another one something else. And there are vivid discussions ongoing. But in principle, we see here, we differentiate with regard to the access type for any object. Do we really want to see this parameter in an object dictionary, in application mode, or in bootloader mode? So we see which kind of functionality shall be available. And therefore, we try to assist people in providing a harmonized solution for handling the firmware update. As I've already said, this activity initiated by the task force generic CAN bootloader intends to provide a harmonized method for updating device firmware via the CAN interface. It tries to consider all these mentioned use cases and derived requirements. So they are a lot, and it's really difficult to provide an acceptable answer for all the attendees in the working group. So there are often vivid discussions, but all the attendees, they often learn from others what are their issues, what are their problems. So also there from my side, a big invitation to you, just come to the next meetings of these groups, although that presented by Holger and Thilo, and bring in your requirements. And on the other hand, you can learn a lot from the other experts for your own projects. So we here in the bootloader mode, we summarize the results in document 710, which is currently under development. And as I've said, the main focus is on CANopen and CANopen FD, but there's also thinkable in a second step that we map the solutions on raw CAN data frames. And finally, as I've already said, it's not the intent to make existing solutions invalid, but just to limit the variety of future implementations, and also to give for future standardization groups at CAN Automation or in other standardization bodies a guideline, what is the recommended handling of the firmware update. Everything. Yeah, if you are interested in that, what we are doing here at CAN Automation and what are the latest activities, then don't forget registering for our mailing services, depending if you are member or non-member. You can register for the info mail or the CiA member news. You can follow us on the social media channels. You have also the possibility to meet us in person at the upcoming InnoTrans. So I had also in the chat discussion on that. We will be there in hall 27, booth 290. We will also present at the Bauma Munich. So if Corona situation allows it, we plan also to attend the SPS in November in Nuremberg. So for all of you that are on site, they can come to us to the booth and discuss their CAN-related issues with us. We would appreciate meeting you there. Tomorrow you can hear at least Holger and myself. We give a short recap about CiA's 30th anniversary in a short webinar format. We will have this year some additional webinars where you can get latest information on certain application fields. Yeah, and latest news also on CAN Automation's website, and we would appreciate also on our email services to answer any question from you. I wish you all the best for your CAN-related projects and hope to see you, meet you soon on any other occasion. Thank you very much. Bye.
Thank you. Bye.